Welcome to Shanti-Peace for Mathematics. In the previous video, we have learned about a limit of a function. So let us recall what is the concept we have dealt with. If you want to say the limit of the functions of two variable f of xy will be L as xy tends to AB for given epsilon greater than 0, there exists a delta greater than 0. That means for given epsilon you have to calculate what should be the delta such that deleted spherical neighborhood or deleted rectangular neighborhood. So here I am taking the rectangular neighborhood definition, which implies mode of f of xy minus L less than epsilon. So geometrically, if you can see this, if you have this is your function, as I told you, z is equal to f of xy is a function, then it will represent the surface. Here you will have a surface, some surface which is the domain, whatever the domain of the function is there, that function is here. There is a point AB in this domain, and the neighborhood of that one we have here, we have considered as this box, rectangular box, and the image of that under this function will be lies on the real line L minus epsilon to L plus epsilon. That will be the neighborhood of L, and this will approaches here as f is a function, because we have taken our function f as some domain D to R, where domain is a subset of R square, and which is an open set. That set has to be contained some neighborhood of AB. So with that revision of the previous video, let us discuss very important concept called the limit, which depends on the paths. If you recall your one variable case, what you have is you have your function is defined or the real line. So if this is x0 and this is x0 minus delta to x0 plus delta, and if you want to calculate if the function is over defined over e to r, where e is a subset of r, it is a one variable case, and if you want to calculate the limit of this function at point x tends to x0, then you know that there will be two limit is there. That means you are approaching to this point via left hand limit and the right hand limit. So that means you are saying that if left hand limit is same as the right hand limit, then we can say that the limit of this function is exist, and that is equal to L. But in the case of two variable or more variable, what is the happening is, if you have, as I told you about that the domain is a two-dimensional, so let us consider this is as a domain of that function. So this is your D, and there is a point AB inside the domain, and if consider this is a neighborhood of this point. Now here in the one variable case, you have this is the neighborhood x0 minus delta to x0 plus delta. To this approaching this x0 by only two paths, there is only two paths is possible you are approaching here. But in the case of two variable, you have many paths to passes through this point, because you can choose this is as a path, one of the path. You may choose this one is a one of the path. So you are approaching to this way, you will allow to approaching this way, or there is another path. So there are infinitely many paths are possible to travel at this point. So when you can say a limit is exist, that means it has to be exit all over all the paths of the function, whatever the paths is there. So due to that, we have one result. Let us discuss that result. So this is the statement of the that result that I'm talking about. D is the subset of R square. So you have, if you are two-dimensional case, if you can consider, if this is your D which is a subset of R square and which contains the neighborhood of AB, so that you will have AB and it contains some neighborhood of this point. Let f be a function which is defined over D to R such that the limit of this function, that means the limit of f of xy, is equal to L as xy tends to AB is exist if you have a g function which is defined on some interval I to D, that means it is any path such that limit of this function g at point A is B or A. You can choose any path passing through this point A and the limit of this function will be B, which is here. So that we have taken in this case. So you can choose, here I have plotted this green line. You can take any path passing through the point AB. The condition is the limit of that function at A should be B. So that is the condition you have. And you have a function h which you define as x, whatever the function of g of x. If it is there, then you can say that the limit of this h of x is L. So whatever the limit of this function, it is the same as the limit of this path you will have as x tends to A. That means if you choose any path passing through this point AB, that will always have the same answer. That is the meaning of this theorem. We are not giving proof for this, but the understanding is more important. The understanding is that a limit is independent with the path. If the limit is exists, whatever the path you choose, the answer will not be a change. So due to that, we'll have one very important theorem. It's called the test for non-existence of a limit. If you want to check that whether the limit of the function is exist or not, so you need to apply this test for non-existence of a limit. It says that if for a function f of xy, either the limit of this function at point AB does not exist along at least one of the path, through AB it is there, it does not exist, or it says that f of x has a different limit along the at least two different paths through AB. That means that if you have, this is your D and there is a point AB, if you have any path passing through this point, if the limit of the first statement says that the limit along this path does not exist, then the limit is not exist. That says, or if you have a two different path passing through this point, and at these two different paths have the different answer, then also you can say that the limit does not exist. So this theorem is very important to check the non-existence of a limit. So in the previous video, what we have discussed is, we have discussed about all the example where the limits are exist. Here we are discussing the examples where the limits does not exist. So with these two theorem, and this is the very most important theorem, with that we will solve lots of example. Let's start with the first example. So that limit xy tends 0 0 x plus y upon x minus y does not exist. So whenever this rational functions are there, whenever the such kind of functions you have given, rational functions means a function which is of the form f of x upon g of x, where here it is a functions of two variables. So you can say that f of xy upon g of xy, where f of xy and g of xy, both of them are a polynomial in terms of x and y. So whenever such kind of things is there, you have to calculate what is the degree of the numerator and the denominator. If the degree will be the same, or the denominator have the more degree, for example, here the degree of x is 1, here is also 1, so total degree I can say it is 1, because with the addition, here is also 1, here it is also 1, so here it is a 1 by 1 degree. So that means whenever such kind of situation is there, the limit does not exist. if the question is to determine the limit is exist or not. So whenever this situation is there, then what you need to do is you need to find out such path on which the limit is depends, or you can find out two different paths. As per this results, you need to find out two different paths where the answers are different. So you can do two things. Now what is happening, you just see that this is the point AB is the origin that you can see here, 0 0. Now there are different paths are possible passes through 0 0. First one is this y equal to x line, y equal to 0 line, x is equal to 0 line. You can take any path, any line passes through origin, that is y equal to mx. Okay, you can have the curve passing through origin, y equal to m x square, that is a parabola. So there are many paths are possible passing through this point. So along any path or along any two different path have the different answer, then the limit does not exist. That you need to prove. That means you need to find out such path on which the limit is depends. So if you change the path, this limit have the different answer. That means limit is not unique. So with that, what you can observe is, if I replace this y by mx, so if what I am doing is I am putting y equal to mx, this is the path along the lines, straight line passes through origin that with the slope m. So m is a parameter, so I am taking m as belongs to r. Now what will happen is, as x tends to 0, you can say that y is also tends to 0, because y is nothing but the mx. So if x is tends to 0, y is tends to 0. Or what is the function f of xy I am having now, that I am putting the value as y equal to mx. So this function will be x plus mx upon x minus mx. Now x will be cancelled out in the numerator and the denominator, so we'll have 1 plus m upon 1 minus m. So this will be the answer. If you take the limit now, limit of f of xy as xy tends to 0 0, this will be nothing but if I replacing this y equal to mx, then that will be gives you x is tends to 0, x mx, and y x mx will gives you the answer is 1 plus m upon 1 minus m, because there is no x is here, so it is independent of x. And this value is depends on m, because if you change the value of m, suppose m is 0, then that will be the line x axis, m is 1, that is another line, m is 2, that is another line. So that means if you choose a different paths, the answer is different. So that's why we can say that this limit does not exist. So the limit of f of xy as xy tends to 0 0 does not exist. Let's have another example. Same, discuss the limit of x raised to 4 y raised to 4 upon x square plus y raised to 4 power 3 as xy tends to 0 0. Discuss the limit of this. That means whether the limit is exist or not. So what I told you, you need to calculate the power in the numerator and in the denominator. So what is the power in the numerator? You will have 8. See, because it is x power 4, y power 4. So 4 plus 4 is 8 is the power in the numerator. What will be the power in the denominator you will have? So this has 2 power, but this will have 4 power. So and these functions are in addition. So that's why this quantity has the power 4 and raised to 3. So that 4 2s are 3. So that means this is of power 12. So the denominator have the more power here. So whenever the powers in the rational functions are in the numerator has the lesser power than the denominator, or both of them have the same power, then most probably the limits of the functions are not exist. Most probably. There are some cases where you will have the limits or does not exist when the numerator have the more power, but most of the cases this is the scenario. Now you need to calculate the two different paths where the answer of both limits is differ. That means they are not same. So you can say that the limit does not exist. So this is our observation. and from that observation now you need to choose a path. So what is the what you can choose as a path? So here it is x power 4. So if I take y is equal to mx as in the previous example if we have taken, what will happen is if you replace that value x power 4 m x power 4 upon x square plus m square m power 4 x power 4, you will have power cube is there. So in the numerator you will x power 8 and in the denominator you will have, it is x raised to 6 will be common out in the denominator and it will have the 0, so the answer will be 0. So all path that answer will, because you can say that it is m power 4 x power 8 upon x power 6 is common out, you will have 1 here plus m power 4 into, you will have x square power cube. Now this x power 6 will cancel out, here you will have x square, and if you take a limit x tends to 0, this will have the answer 0. So that means this path will not be, because we can say that at each and every path of this will have the same answer. So we cannot apply this y is equal to mx here in the same manner. So you have to take some another path. You can have something here, so that quantity will depends on m. If it is depends on m, we can say that the path, the limit is a path dependent, so that's why it is not existing. So with that, what we can do is, here in the denominator if I common out something, some quantity, so that to turn out to be x power 12 or y power 12. So I need to some set up in the manner that you have the something is common is x power 12 or y power 12. So with that keep in mind, what I'm taking as x is equal to my square. So if I take x is equal to my square, this is also parabola which is passes through origin. So instead of y I'm taking as x equal to, so I'm just putting it is xy, in place of x I'm just replacing my square comma y, and if you replace this value in the above function, the above function is x power 4, that is my square power 4 y power 4 upon m square y power 4 plus y power 4 power cube. Now what will happen is, due to this x square, this and this y square, this will become y power 4. So this y power 4 will get common out and that will be 12. Here is also you can say that it is 4 into 2, it is 8 plus 4, so it is m raised to 4 y raised to 12 upon m square plus 1 cube into y raised to 12, because y raised to 4 is common out, power cube is y raised to 2. So that will cancel out and you will have m power 4 upon m square plus 1 power cube. And if you take a limit, y tends to 0 here, because as you have x, y tends to 0, 0, 0, you will have y tends to 0, and as per the function which we have taken, x is equal to my square, your y is tends to 0, x is already tends to 0. So x is tends to 0, y is tends to 0. So that function f of x y will be m power 4 upon m square plus 1 whole cube, which depends on m. So that means we can say that the limit does not exist. If you change the value of m, the limit is differ. So that's why the limit does not exist. Let's have the another example. Limit square y square upon x square y square plus x minus y raised to 4 xy tends to 0, 0. So here is also you can observe, in the numerator you will have the 4 power, so degree of the numerator is 4. Here it is a 2 plus 2 4, and here it is also 4. So in the denominator also it is a 4. So numerator and the denominator have the same degree of the terms. So that's why here it is easy to choose as a function. You take as a y equal to mx as a function. you take y equal to mx, it will have x square. So what is your f of x mx will gives you x square m square x square. If you replace y by mx, you will have m square x square upon x square m square x square plus x minus mx whole raised to 4. Now x power 4 is common. Here it is x square is cancelled out, x square is cancelled out, this x square will cancel with this, and this x is x power 4 will cancel with this. So the finally what is you will have is m square plus 1 minus m power 4, which if you take a limit x tends to 0 to this x mx, will have the answer m square plus 1 minus m whole power 4, which depends on m. So we can say that the limit of this function is also not exist. Let's have the another fourth example. A limit of xy tends to 0 0 x power 5 on to y upon x power 10 plus y square. So here what will be the power here? In the numerator you will have a 6 power because it is a 5 and its power as 1, and both the functions are on the multiplication, that's why that powers are added. Here the functions are in the summation, and this is a power 10, this has a power 2, so maximum power is 10. So that means in the denominator you will have the power 10. So in this example the denominator have the more power. So that's why here is also there are chances are there that the limit does not exist. So you need to choose some path which that curve has to be passes through 0 0, so that the limit of this will depends on that path. So what will be your path, what you can choose, so what you can choose y equal to or something as x is equal to, so that you will have some cancellation, so you have a common term is common out and you will have some answer. So here the question is there are a difference of 4 is there, x power 5 is already there, and here it is x power 10 is there. So I need to have some y, it is in terms of x power 5, so that's why x power 10 should be common out and it will cancel. So what that gives me idea that I can put y equal to mx power 5. If I put y equal to mx power 5, f of x y, that is mx power 5, that will gives me x power 5 into mx power 5 upon, in the denominator it is x power 10 plus m square x power 10, because it is y square, so it is m power 5 whole square is there, so that's why it is m square x power 10, and this x power 5 plus x power 5, that is multiplication, so powers are added, so that will cancel, it is x power 10 which will cancel with this. So the answer is m upon 1 plus m square, and if you take the limit here x tends to 0, f of x into mx power 5, that will have the answer 1 upon 1 plus m square, which depends on m. So that's why if you change the value of m, a limit of the function is changing, so that's why it is a path dependent, so that's why the limit of this function is also not exist. Let's have the another example. The logic of that example is not same as the previous example. Let's have the limit of x cube plus y cube upon x minus y, xy tends to 0 0. Now here what is happening, as I told you in the above example, you have just work out with the power. So here the numerator has the 3 power, the denominator has the 1 power. The logic what we have discussed above, it's not worked here, because here also the limit is not exist, and the path is also very tricky one that you can take it as. So here I am choosing as a path as x minus y equal to m x cube. this path is also passes through origin. You can see that by putting x is equal to 0 0, this both the sides will satisfy. So this is one of the path which passes through origin. So that means what we are taking, as I am taking y equal to x minus m x cube, I am putting into this equation. So what you will have is f of x y I am putting x minus m x cube. So that will gives me x cube plus x minus m x cube whole cube upon, you will have the function is x minus y, so it is x minus m x cube. So what will happen, in the numerator you will have x cube is common. What will happen is, what is left is 1 plus 1 minus m x square whole cube. In the denominator what you will have is, this x will cancel with this x and this minus minus become plus, so it is m x cube. So m x cube will cancel out. So the finally the answer of this quantity will be this. And if you take a limit xy tends to 0 0, f of xy will gives you limit of this function f of x comma x minus m x cube as x tends to 0, because as x tends to 0 your y is also tends to 0. So that's why this will gives me a limit of x tends to 0, 1 plus 1 minus m x square upon cube upon m. Here there is x, so if I take a limit here, so it is 1 plus 1 minus 0 power cube upon m. So the finally you will have 2 upon m, and it will, this is also depends on m, so that's why the limit of this function is this. So this is actually the exceptional example that we have discussed, in that the logic what I am telling you in the above example is not working. So that's it for this video. Let us recall what we have did in this. So we have discussed the limit of f of xy will be L, xy tends to AB is a path independent. So if you have a two different path or any path, there are infinitely many paths passes through AB is possible, all the paths have the same answer, then we can say the limit is exist. Or we can say that if the limit is exist, all paths have the same answer. With that we have one corollary, that result is says that if you have a two different paths having the two different answer of the limit, or if at least there is one path where the limit of the function is not exist, we can say that the limit of the function is not exist. And based on that we have solved lots of examples here. So I am giving you some exercise here, you can try for that. Check whether x cube plus y cube upon x square plus y square as xy tends to 0 0 have the limit exist or not. So another example that I am giving you is, check for this limit of xy tends to 0 0 tan inverse of y by x, whether the limit of these two functions are exist. Try to find out. So thanks for watching this video. If you have liked this video, please press the like button. If you have any comment, questions or any suggestions, please drop down in a comment box below. Thank you. Bye bye. Sayonara.